9.1 in our textbook covers adding and subtracting polynomials. So let's take a look. First of all, it might be a good idea to know what a polynomial is and what it's made up of and what are the different types. So one particular type of polynomial that we work with is called a monomial. Okay, so let's take a look what a monomial looks like. Mono, if you look at the prefix, not in Spanish. Spanish mono means hand, but mono in English, it's like singular, right? Monotheism, monopoly, things like that. So if I take a look at that, here are some examples of monomials. Negative 5x. Okay, so it's got a sign, a number, and sometimes a variable. Or 2w. Well, that's a sign, positive 2 and a w. Okay, good. Or it could just be the sign and the number without a variable. Negative 10. Perfect. All those are examples of monomials. Just one single term, one single term, one single term. Now, if we put these terms together, we have two. It's called a binomial, like a bicycle, bicentennial. Means two, right? So 1, 2 terms. It's got a number. There's that little invisible 1 there, but it's not imaginary, it's invisible. 1x. There you go. Positive 1x, positive 2. Next one over here, they're split up between their signs. I got a positive 7x squared y, that's one term. Negative 15x, that's the second term. So that's a binomial. 3 terms, like a tricycle or a triangle. A trinomial means 3 terms. So here we have positive 1x squared, that's 1. Positive 1x and positive 1. Over here, I've got positive 20w squared, positive 5w, negative 11. Those are 3 terms. So monomial, binomial, trinomial. Anything more than that is just called a polynomial. Okay, we don't have words for 4, 5, 6, 7, 8 that we use typically, so we use monomial, binomial, trinomial. Anything else is called a polynomial. All right. These are still considered polynomials, but they're specific. Okay. All right, so let's take a look at an example. Here's my example. Example number 1. I'm adding a trinomial with another trinomial. 3 terms, 3 terms, and 3 terms. So here we go. It's like adding like terms. And what I tell you in class, I say, look, parentheses means do that first, right? PEMDAS, remember that. Well, I can't combine 3x squared with an x. These are not the same type. And I can't combine the negative 6 with the x. They don't have like terms. So the next thing I do is I take care of my parentheses. I look out front. What's out front? I don't see anything, so there really is a 1. So it's asking me one of these, one of those, and one of those. Well, that's easy. I'm going to write it without parentheses. So 3x squared, positive x, negative 6. Same thing over here. Inside the parenthesis, I cannot combine those terms. There's this 1 out front, so I want one of those, and one of those. Say no problem. Here's one of those, one of the 4x's, and 110. Now it's a matter of just combining like terms. And combining like terms is pretty simple. We can just look for the variable part. 3x squared, where else do I see x squared? Aha, right here. But you say, Mr. Ramos, I don't have a number there. Ah, there's my ninja 1. Sometimes you see them, sometimes you don't, but there it is. So if I write it that way, you might say, oh, well, that's much easier. That's going to be 3 plus 1 is 4x squared. Next term, my x. Where do I see another x? Oh, right here. There's 4 of them. So this one also has a little ninja 1. 1x plus 4x, that's going to give me 5x. Last but not least, my constant, negative 6. I got another constant over here. It doesn't have a variable, neither does that. So I can combine them together. They're friendly, and there you go. So there's my final answer when I combine those polynomials. All right, so that was the slow version of what you should know. Let's go take a look at another example. Once again, I have parentheses. I cannot combine anything, so I'm asking for one of each, right? One of each. So I'm going to go 1 4m squared, 1 negative m, and 1 of the 2's. Got it. Second one, it's asking me again for just 1 of each, a positive 1 of each. Okay, so 1 of the negative 3m squareds, negative 3m squared, 1 10m, and 1 7. Now, I'm going to go ahead and find my like terms. Here we go. We start with m squareds. I got 4m squareds here, negative 3m squareds there. So together, that just leaves me with 1m squared. We don't need to put a 1 out front because we know it's there. Negative m. I see another m over here. Negative m, negative 1m, remember. With positive 10m is going to give me 9m. Last but not least, my constants, positive 2 and positive 7 is going to give me positive 9. And so there's my final answer. I think you're getting the hang of this, but let me throw you a curveball. Can you handle it? Here we go. We take a look at this inside the parentheses. Can't combine anything. I remember Mr. Ramos saying there's one of them, so I'm going to write one of each. That's 1 9b cubed, negative 13b squared, positive b. Aha. Over here, don't get fooled. This negative is a little different from before. This negative is saying, hey, friend, I want the opposite. I want one of the opposites of each one of these. The opposite. Opposite. Well, the opposite of a negative is positive. So positive 13b squared. The opposite of a negative 5b, positive 5b. And last but not least, the opposite of a positive 14, negative 14. Now it's just a matter of matching the things that go together. So here I go. B cubed, 9b cubed. I don't see any other b cubed. So guess what? All by yourself. Aww. All right, moving on. Negative 13b squared. Positive 13b squared. Oh, they challenge each other. They cross each other out. They're exact opposites. Zero pairs, if you will. B. Hey, I got some more b's over here. I got one b here because there's that little ninja one. And 5 b's there, so that's a total of 6 b's. Scary. And then last but not least, my constant, he's all by himself again. He says, hey, it's okay. I can be by myself. Let me write it just like that. And there is my answer. That's how you add polynomials.